Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. So, what is today's topics? Today's topics is air entrained concrete. Now, what is the air entrained concrete? What is the IS code specification? What is the concept and mechanism? And why it is differ from the normal concrete, and why we need air entrained concrete. In today's video, I will discuss each and everything in details. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. And the topics is air entrained concrete. So what exactly is air entrained concrete? Simply put, it's concrete that contains of microscopic air bubbles intentionally introduced by using admixture called air entraining. We air the concrete through air entraining agents. So what is the purpose? This bubble acts as tiny shock absorbers, giving concrete the flexibility to withstand freezing, thawing, and other stresses. Unlike normal concrete, which is dense and rigid, air entrained concrete maintains durability even in extreme environments, making it highly reliable for pavements, bridges, and runways. So, this is the air entrained concrete. Now, here is the terms is coming air entraining agents. So, what is the air entraining agents? It's giving the definition in IS 910 of air entraining admixtures. An admixture for concrete or mortar which causes air to be incorporated in the form of minute bubbles in the concrete or mortar during mixing, usually to increase the workability and resistance to freezing and thawing and disruptive action of de-icing of salt. So here it is given that we are adding admixture in the form of air bubbles to create inside the concrete. So why it is required? Because it is the resistance of freezing and thawing cycle. What is happening in the cold region when the temperature falls below the icing temperature, the water inside the concrete become frozen, and when it is formed the ice, we know that it increases the volumes at 9%. So what is happening? This volume increase and it creates the internal tensile stresses, and it causes cracks, spalling, and everything for the concrete, and it's deteriorated strength and the durability of the concrete. To encounter this, we are adding this air entraining admixtures. Now if you want to know more about freezing and thawing cycle, I have made a detailed video, you can check, and you will get the full information about this. The link is in the description. Now what is the mechanism of air entraining agent? Now how it is work? Now what are the different principle that reduces the surface tension of water? It helps trap the stabilizes small air bubbles during mixing. These bubbles remain stable in hardened concrete, acting like pressure relief valves again freeze-thaw cycle. Now, what is the mechanism? When concrete is mixed, agitations not naturally forms tiny air bubbles. But without air entering agent, these bubbles rise and escape quickly because water has high surface tension. So what is the air bubble is normally formed? It is not containing inside the concrete. It releases or even escape because of the high surface tension. So with an admixture, air entering admixture, molecules surrounded each bubbles, creating a stable film around it. So how it is formed? That is the absorption of air water interference. How it is work? They create the hydrophobic tail which is repels water and faces in the air bubbles, and hydrophilic head attract to water faces outwards into the liquid. This arrangement reduces bubble collapse, forming a stable muscle-like structure. So in the normal concrete also, if you create the bubbles, what will happen? This bubble will escape from the concrete due to high surface tension of the water. But whenever you're adding air entraining agents in the mixing, they create a hydrophobic tail and hydrophobic head. This becomes a stable structure escaping from the concrete. Now when uniform dispersion, what is it? The continuous mixing plus surfactant action breaks larger air pockets into many small pockets. These are spherical, well shaped and closed pores, unlike honeycombing voids. Now what is how it is work? See, first is freezing in of water in concrete pores. Concrete always contains some pore water, that's or the capillary pores or the gel pores. The water can inside the concrete in two forms, in the capillary pores and the gel pores. And when temperature in large pore freeze fast, ice, I already know that occupies 9% more volume than liquid water. Expansion generates hydraulic pressures in surrounding unfrozen water. This pressure tries to force water into adjacent pores. Now, what is happening? The volume is increasing and it generates hydraulic pressure and it is tries to force water into adjacent pores. Now, problems, what will happen without air entering agents? In plain concrete, no air entrained concrete, water has no escape chamber. Expansion pressure built up in the cement matrix and around aggregates. The repeated cycle cause microscopic scaling, spalling, and structural damage. Now, what is a role of air entering air bubbles? Because now bubbles to release this pressure. So, air entering agents creates uniformly distributed micropores bubbles. During freezing, these bubbles act as the pressure relief valves. As ice forms and expands, it pushes unfrozen water toward the nearest air bubble. These bubbles absorb the pressure, preventing crack formation. This spacing factor is critical, should be less than 200 micron as per durability requirement. Now, this air entraining agent also works another way, that is osmotic pressure relief. And what is that? As ice forms in large capillaries, it lowers vapor pressure, pulling water out of gel pores. Now, it is happened, there is already this, there are the two types of water escaping in the capillary pores and the gel pores. Now, when the ice forms the large capillaries, it lowers water vapor, and when the water vapor pressure is lowers, it will pulling the water from the gel pores. These create osmotic suction, causing stress in the paste. Entraining airways break this suction spot by providing dead ends, reducing osmotic stress. So not only the freezing thawing cycle, it also helps to reduces the osmotic pressure relief. Now, what is during the thawing? What is happening when ice melts? Pressure inside bubbles equals gradually. Entrained air voids remain intact, ready to the next freeze cycle, because again is the hydrophobic tail and hydrophobic head the formation. These voids become stable, and because they are non-interconnected, they do not allow leakage of water, only serve as expansion chamber. Now, cyclic freeze-thaw cycle, what is happening? Each freeze-thaw cycle, like inflating, deflating of a balloon inside a concrete, entrained bubbles keeps the stress localized and relieved. So, what is the laboratory studies saying? That an air-entrained concrete can withstand hundred of cycles with minimal damage, but no air-entrained concrete may fall with 20 to 50 cycles in severe frost. Now, we need to know what are the different types of air entraining agents in we can use in the concrete. So, animal and vegetable fats and oils and their fatty acids, natural wood resins which react with lime in the cement to form a soluble resinate. These resin may be re-neutralized with NaOH so that a water-soluble soap of a resin acid is obtained. And then wetting agents such as alkali salts of sulfated and sulfonated organic compounds. So these are all the different types of air entering agents we can use, but we need to know what are the factor influencing air entertainment, because all we know this is a great purpose for the freezing styles and osmotic pressure, but we need to know what is the influence that is affecting this air entrainment. So what is the factor? The first is a more workable mix holds more air than a drier mix. An increase in the fitness of the cement, an increase in the fineness of cement decrease the effectiveness of air entraining. So you need to check what is the fineness of cement also. Alkali content in the cement greater than 0.8% can increase the amount of entrained air. An increase in carbon content of fly ash decrease the amount of entrained air. The use of water reducing admixture can also be, this is very fast rotation of the mixture increase the amount of entrant air. Higher temperature leads to greater loss of air. Transportation and prolonged vibration reduce the amount of entrant air, and excess of very fine sand particle reduces the amount of entrant air. So you need to check the sieve of the sand particles also. So these are all the factors that can affect the mechanism, or that can the if work of the air entraining agents inside the air. So whenever, so what is the benefits of air entraining concrete? That is, all we know that you improved workability. The tiny bubbles act like a ball bearing, making concrete easier to place and finish. And resistance to freeze-thaw cycle, already I discussed. Better durability. The service lives of concrete structure increase significantly, reduces blending and segregation. Importance of the air entraining concrete. Now, what is the IS code? That is IS 9103. It is given the specification for admixture for the concrete. It is given what is the requirement of air entraining concrete, and the typical recommendation is 4 to 7% by volume of concrete. And testing is IS 1199. There are two methods. There is the pressure method and the volumetric method. But whenever you are dealing with the air entraining concrete, you need to check the air percentage or air volume percentage in the mix. So whenever you are receiving the concrete, you need to check the air volume inside the mix, because this is a must. Otherwise it may fall, or it may not give the better quality. And application, what is that? Is a highway, pavement and airports and bridges, dams and hydraulic structures, cold climate construction where freeze-thaw cycles are common. And what is the limitation? It reduces compressive strength slightly. So in a very high strength structural member, it is not recommended. It should not be used in structure where water tightness is more important than friction resistance, for example water tanks and warm climates. And what the quality control and field check ones, that's so these are all about the air entrained concrete. And I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you'll get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.